Check whether the decimal representation of the following rational numbers is terminating or non-terminating and recurring. So we are given few rational numbers and we have to find whether the decimal representation of these rational numbers will be terminating or non-terminating and recurring. So we don't have to actually divide them and see. The idea is to see a rational number and directly identify whether its decimal value would be this case or this case. So how can we do that? In the last video, we saw that in order for a decimal representation of a rational number to be terminating, we should have a power of 10 in the denominator. And if you haven't watched that video, I would suggest you to pause this video here, watch that video, and then come back here. So let's start with the first one. Now we need a 10 or a power of 10 in the denominator. In order to get a 10, I should have 2 multiplied with a 5. 2 times 5 is 10. If I need 10 square, basically I need 2 2's and 2 5's. If I need 10 cube, I need 3 2's and 3 5's. So I can only get a terminating decimal if I would have something of this form. If I would have factors, if I can write this in the forms of 2's and 5's only, then I can say that it is terminating. If there is any other possibility, let's say that we have 2 cube times 5 cube times 3. Now I cannot change this into a power of 10. So if I have such prime factorization in the denominator, I would say that its decimal representation won't be terminating, but rather it will be non-terminating and recurring. Let's actually see one example. Let's say that we have this. Let's start with the denominator 455. Let's try to prime factorize that. So 455, we can write this as 5 times 5 9s are 45 and 5 1s are 5. 5 times 91. Now let's try to split this further. So this we can write it as 5 times 7 is a factor of 91. So we can write this as 7 times 7 1s are 7 and 7 2s are 14, 7 3s are 21. 7 times 13. So 455 is basically 5 times 7 times 13. So this 64 upon 455 can be written as 64 upon 5 times 7 times 13. Now, is there a possibility to get a power of 10 in the denominator? Let's see. I have 1 5 if I would multiply both numerator and denominator with a 2. So this 2 and this 5 would combine and give me 110. But what should I multiply this denominator with so that I can change this 10 and 13 again into 10? That's not possible because I can get 10 only if I have a 2 or a 5. I have to take a combination of 2 and 5 to get a 10. But since we have 7 and 13, I can never get a power of 10 in the denominator, which means 64 upon 455 will not have a terminating decimal representation, but rather have a non-terminating and recurring decimal representation. So this is the idea. I think you got the idea. Okay, whatever denominator we have here, first of all, we need to prime factorize this. And if we have any other prime factor other than 2 or 5, this would mean that we can never convert that into a power of 10. We should make this non-terminating and recurring. So if we have only 2's and 5's in the denominator, we would say that the decimal representation would be terminating. If we have any other factor other than 2 and 5, then we would say it would be non-terminating and recurring. Let's try other example. We have 15 upon 1600. 15 upon 1600. So let's start with the denominator and let's try to prime factorize that. So 1600, basically we can write 16 times 100. 16 is 4 times 4 and 100 is 10 square. So we can write this 10 times 10. Again, let's try to split this further. 4 is actually 2 square. So 2 square times 2 square, we have 4 2's. So we can write 2 to the power 4 times 2 times 5 and 2 times 5. So this would finally give us, we have 4, 5, 6, total 6 2's, so 2 to the power 6 times we have 2 5's, 5, square. So we only have 2's and 5's in the denominator as the prime factorization of 1600. So this would mean that the decimal representation of this rational number would be terminating. And just to make this clear why, let me just do quick simplification. So 15 upon 1600, instead of 1600 we can write 2 to the power 6 times 5 square. Now we know that 1 2 and 1 5 would combine together and give me a 10. We already have 2 5's which would combine with 2 2's to give us 100. So we would be left with 4 2's here. So if I can multiply both numerator and denominator with 4 5's, each of the 5's would combine with each of the 2's and give me 110. So finally I would have a denominator which would be a power of 10. And hence, if I have a power of 10, I can say that its decimal value would be terminating. So this is the logic behind this. So we don't have to do this like for each and every question. It's just that we need to see, do we have only 2's and 5's in the denominator? If yes, it means that its decimal value would be terminating. If not, if there is any other prime factor, we would say that its decimal representation would be non-terminating and recurring. Let's try the last example. The last example is 129 upon 2 square times 5 to the power 7 times 7 to the power 5. So this is already given in its prime factorized form. So we have 2 2's and 7 5's. So we can say that 2 times 2 times 5 times 5 times 5 times 5 times 5 times 5. 1 2 3 4 5 6 and 7, and we have 5 7's as well. So this 2 and this 5 would combine and give me a 10. This 2 and this 5 would combine and give me a 10. We would be left with 5 5's. So we can multiply this numerator and denominator with 5 2's, that is 2 to the power 5, and each of these 2's will combine with each of these 5's to give us 10 and power of 10. But what about these 7? Can we multiply anything with this 7 to get a power of 10? Nope. So that's why the decimal representation of this rational number would be non-terminating and recurring. And also we can directly see here that we have other prime factor other than 2 and 5. That is, we have 7 as the prime factor. So I would say that, as we discussed, that if we have any other prime factor other than 2 and 5, we can directly say that the decimal representation would be non-terminating and recurring. One last thing, just to clarify this to the last possible extent, I can say that let's take one example that we have 4 upon 5 square. So will its decimal representation be terminating or non-terminating and recurring? Why don't you pause the video and try this on your own? Well, we have 2 5's, and as we discussed, if we have 2 or 5 with any possible power, or let's say that this is m, this is n, where m and n are whole numbers, which means either of them can be 0 as well. So if this case is available, if we have this case, then we would say that its decimal representation would be terminating. Why? Because we have 2 5's, we can multiply both numerator and denominator with 2 2's, and each of these 2's would combine with each of these 5's to give me 10 times 10, that is 100, a power of 10 in the denominator. Similarly, let's say that we had, instead of 5 square, let's say that we had 2 cube, let's say 4 upon 2 cube. Then we can do the same thing. We can multiply both numerator and denominator with 3 5's to get a power of 10 in the denominator. So I think you should, after all this explanation, I would like you to understand why are we doing this. But finally, I would just end this video by just saying that if you want to identify whether the decimal representation of a rational number is terminating, it should only have the denominator of that rational number should be in the form 2 to the power m times 5 to the power n, where m and n are whole numbers and no other prime factor should be present. If the denominator satisfies this condition, like we have seen in these examples, then it will be terminating. If there is any other prime factor, we would say that it is non-terminating and recurring.